right? So these data types are the derived from the fundamental data types, and the variables of derived data types allows us to store the multiple values of the same type in one variable, but never allows us to store the multiple values of different types. Okay, so in that case, when we have already seen that array is the example of the derived data type. Okay, so arrays is the collection of the similar data type, right? So example, we can say the array of the integer values. So integer values means, suppose I have given the example int string 10 character. Now what this means, it is holding the value or holding the character that is having the dimension 10. That means 10 characters you can store at a time for the variable string. Okay, so variable string you can allow that the multiple type of integer. Now case whether it is given variable name, nothing that is important, but the type is important in this case. So it will store the type integer. Okay. Similarly, next derived type, we say that the function is there. So a function definition introduces a new user defined function to the program by the declaring the type of value it returns and its parameters, and specifying the statements that are executed when the function is called. So this can
Namaskar.
C++ that we say that the function definition is also a new user defined function to the program. Okay, so similarly, the next is the pointer. Pointer, we know that pointer is again a type where we can allocate, or we can have the allocation of the memory where we are putting that or staying that towards the giving pointed by some variable. So pointers in C++, if used properly, give way to faster programs and efficient code. Okay, if we use a pointer in efficient way, it is like faster program execution takes place. But if they are misused, they could lead to huge programs crashing without as much as like not giving the warning, and it will crash your program. Okay, so pointers. Then the next is the reference. Reference variables are also used. Reference variable means it is giving another name to the memory, same memory location earlierly you have declared by some other another variable. Okay, so that is the reference variable. So we can say that another derived type our we are having a structure. Next is structure. So data type, user defined data types we are using in C++ structure as well. So what is now structure? It defines a new data type with more than one member variable. It defines a new data type with more than one member variable. That means it's a combination or collection of different data types. It is a collection or combination of different data types. That is, suppose I am declaring a structure for books. How I will write then? I will write struct and the books as the name of the structure. Struct followed with the name of the structure, that is books. Inside that we are having the character title for that book. Okay, then character author for that book, then character subject for that book, and in integer the book ID. Okay, then followed with the closing brace and the semicolon, followed with the closing brace and the semicolon. So how you are going to form a structure, or what is the way to form a structure? It is like a user defined data type having the collection of different type of structures or data types. Here we are using the character, integer. Similarly, we can use the float or double or strings. Okay, so that makes us use of the collection of different data types with the help of the structure. With the help of structure you can define the new data type or a user defined data type. An example I have put here for the books. Okay, so I can declare here this is a structure formation. Okay, it is a structure formation and it gives allocation only when its variable is declared. Only when its variable is declared. Now you have not declared, you have just formation of structure you have done for the books. And when you declare the structure variable, you have to declare inside the main again. When you are using the main, you are going to declare it. Okay. So in the main program, you are going to declare about the how the structure or the name of the structure and what is the structure used, that is struct books and the book 1, suppose that is the variable. When you declare that book 1, that means you are allocating the memory for this structure books with the help of the variable, that is book 1, and it will allocate the memory for title, author, subject and book id. It will allocate a memory in the memory location for all this type of data members. It is a data members of the books. Okay. So how you are going to access that structure? I'm going to give that example again. Okay. So after that, the next user defined data type is union. You might have heard union. So union is again a next new type of derived data type, user defined type that uses the same block of memory for each of its list members. For example, suppose you are declaring a student as a union structure. So this is union, given a name student to that union, and then informing the different members of that union are integer roll number, integer phone number and float percentage. So you are gathering the data that about the student and forming that integer roll number, then again phone number and the percentage value for that student. So it is a collection of again the different data types, different members inside. Now you are having again same structure like a structure. Union also have that memory allocation when its variable is declared. When its variable is declared. So now what is the difference then if they are both are same? What is the difference then? Structure and union are same then? No, they are not same. Actually, declaration part is same, but the allocation part is different. Okay, so for structure, if you look the example here on the screen, structure is having the allocation for the data members differently. If suppose I have put here the structure Greek for Greeks, uh, this is a name for the structure, and in that assigning the data members character x, float, y and their object followed with the object declaration. Okay. Similarly in union Greek for Greeks followed inside that character x, float, y and the object. So in this structure type of thing, everybody gets the memory allocation. Like character will get the memory allocation, float will get the memory allocation. If other variables are there, that will get the another memory allocation in structure. But in union, what happened? In union, it will find out which data type is having the more bytes to allocate. Now, for example, here the float y is having the more bytes than the character x. Okay, so what it will do? It will just allocate a memory allocation for the float variable y. Okay, so it will allocate a memory allocation for float variable y only. Y will allocate the memory allocation and character x will not allocate a memory. So the memory, whatever allocated for the variable y, will be shared by the character x also, by the character x also. So sometimes the union data type, derived data type can be used for our programming and sometimes structure is used for the programming. So that is the difference. The structure all the members will allocate the memory accordingly their data type. Suppose it is integer, it will take 2 bytes. Suppose it is float, it will take 4 bytes. Suppose it is character, it will take 1 byte. And in union, whatever the largest data type that is holding inside the union, that only get the memory allocation, and that will used by the other variables also in sharing manner. Okay, so if you look here, it is having the float that is a 4 bytes, and this will get allocated for the float y, and this will be shared by the character x whenever it is executing at that time. So first it will allocate that whatever the float y 4 bytes, out of this memory only this character x will be utilized at the time of its memory allocation. Okay, so that is the difference. Then next is the example of union. Example is put up here for the union. Hash include iostream, hash include C string, and using the namespace standard, union student is given, which is having the integer roll number, integer phone number, followed with the semicolon. Just union you have formed here the student having the roll number and phone number. You can add more variables also if you want. Then main program execution. Okay, so for main program execution, what you are doing, union student and its variable, union student and its variable is p1. Okay, now p1 dot, how you are going to access the data members? By using the dot operator. So here the variable, union variable is p1, accessed with the dot operator, and then the data member is roll number is equal to 12. You are assigning the value 12 to roll number. Similarly, p1 dot phone number, and you are assigning the value phone number to that variable of union phone number. Then you are having the next is the cout statement. Cout statement will print out or the display the roll number as well as the phone number for the our whatever the variables we have already assigned values, roll number 12 and phone number, that value, and it will display out. So for display out, you are using the cout statement, right? Then the return 0, and then the closing brace. So your execution will get when you execute this, then you will get the output that roll number colon the value of roll number and the phone number value. So here as roll number, okay, output is like only 12 will you will get. Okay, uh, and phone number is having the phone number value is getting, right? Then next is user defined data type class. As we are coming to the class, it defines a new data type with more than one member variables and the member functions. So or we call it as a member mm, we have the member function which have the access to the member variables of the class. Only functions can access the member variables of the class. Okay, but before that structure and union we can have that overview, that is only the structure is formed and the variable inside that the we have used. Okay, but class is something which will allocate the use of the member variable as well as a member function. It is a collection of this member as well as member functions. All right, so we have our next user defined data type is. Okay, one example is put up here. The same class, instead of now structure, we are using the class book. We are having the members, character title, character author, and then we are having the method. By default, if you are not providing it, the access specifier, it is a private. Okay, so if you are not writing here anything, it becomes private. The next is your member function, that is a void get book and void show book. These are the procedures which will access this title and author. Okay, so this is a class book example. In this we are going to just make a blueprint for the class book. We are not allocated any type of variable for it. And if we allocate that variable, that is called as object for that particular class. Okay. So next is enumerations. Again, these are the again user defined data types. Enumerations are used to define symbolic constants. For example, if we are having a specific list of things or list of data, that list of data is known to you, that list of data is known to you, then you can use the enumerations. So for enumerations, you have to make the list. Okay. So for example, you have used some enum is a keyword, okay, followed with the name of the enum. Here we are giving the name direction, right? Now you are to use that list, whatever the values for that direction, you have to use that. So I am putting that east, west, north and south. Apart from this list, nothing is allocated to your enum direction. Only these four values to be allocated. Whenever allocation is done for the values, it has to be sorted out from this direction list only. So enum is a keyword followed with the name of the enum. In this case, in this example, we are giving a name direction, and direction is followed with the list which we are going to give as an option to our values of the direction. That next is it is followed with the main function direction. Direction is equal to, now you are assigning the value. Now direction is the name of the enum followed with the variable of the direction, and that variable is equal to having the some value out of this four values only. Out of this four values only. Okay. Similarly, you can display it out with the help of the cout statement, and then again you can display out the values. So you will get the cout. Now suppose you are having this the list value, because I am saying that it is a list value, it will allocate a list value starting with the zeroth index. So east will take the zeroth value, west will take one value, then north will take two value, and south will take as a three value. Okay, so likewise it will continue. So it will now just display out the which value from the list it has taken. So output will be considered as the direction or the assignment of the value, which assignment value you are taking. Okay, so this is a you are having a north first time, so it is taking the two value, and next time it is taking a value east, so it is giving a list count value that is 0. So similarly, the next example is there. When there is a list that is a confirm values, so you can use the enumerations type of derived data type instead of other data types. Okay, so enumerations are mainly used whenever the list is, you know very well that list is having the particular values, and apart from that values you are not choosing other values. So similarly, for the enum gender, you are assigning the value male comma female. Your list is over. Only two values for gender, right? Then you can use that as a gender. This is the name of the enumeration, and you have given the variable name for enumeration as gender, which is equal to, now you are assigning the value male. When you are assigning this value from the list, it is list is having only two value, that is from 0 first male and 1 that is female. Okay, so you are assigning the zeroth value, right? You are assigning male, that means you are assigning from list the zeroth value. Now you can apply this for the further type of processing. If further processing, suppose which case you are using and you are passing it gender, then you are having the cases, then male, then see out the gender is male, then case next female, then you are making it as female. and for default value can be male or female, so it is returning like this. So it is a simple example showing the how we can use the enumeration type of user defined data types. So all these types of user defined data types we can use in our programming. Okay, so structure can be used, unions can be used, classes can be used, similarly enumerations can be used. So everything whichever can be applied in C++ language we can use that, then only we can understand how what is the use of this after using it. Okay, so this is the all user defined data types which we have discussed right now. The next topic for us is the control structures. Okay, we know that the control structures, what is the use of control structures in C++, has only three types of control structures which we refer as control statements also. So everybody knows the sequence statement. Sequence statement is a series of statements that executes one after another. Okay, as first instruction comes, first instruction is executed, second comes, second executed, likewise it controls in the sequence manner. Then the selection statements are there. Then for selection particular condition is given, and if condition that satisfies, then it will execute the statement after that condition. If it is not statement is that condition is true, then it will execute the latter part. So there are again three statements for that: if statement, if else statement, and the switch case. So if and if else, it is like if this condition is true, the statement is executed. If that condition is true, then the else part is executed. And for a switch case, out of many choices, you can choose one of the choice. From many, one choice. Okay. Then the repetition statements are there. For repetition statement, while loop is there, for loop is there, and do while loop is there. These are the only control structures. Apart from this, you cannot use different one. Okay, so next is the control structures. Sequence control structure flow is similarly one statement, second statement, or the third. Similarly, selection control, as I have told you, condition is specified there. If it is true, then the action is done. If it is false, then the other action is done. And do while control structure depends upon the condition, whether it is a condition, and the block of instructions are executed if condition is true, and if it is false, it will come out of the loop. It will come out of the loop. Okay, so for the examples, if you want to go through examples, I will give you the examples again for this. And this is similar, very similar to our C language control structure. Same way we can use these control structures in our C++ language. Okay, if you want to do the examples, I can put the examples and you can just implement that example through our G++ compiler. Then next is the arrays and the strings. So arrays, everybody knows that arrays is a collection of similar type of data elements. An array in C++ is a collection of items stored at the contiguous memory locations, and the elements can be accessed randomly using the indices of an array. So here we can have putting the example array indices, and it is having one by one, starting with the zeroth index. Index wise contiguous memory allocation is done for our array elements. Okay, so array length, then array indices, how we can access with the help of the array index. Every element can be accessed of our user defined data type, that is array. So this is a array. Then strings. Strings represent the sequence of character. So we can have the sequence of character under the string. So again, putting the some small program here. Hash include IO stream using namespace standard. Int main character greeting, in that you are assigning individual characters, and initialization is done with the help of opening and closing brace and followed with the semicolon. So whatever you are giving, that followed with the null character, that is null character, that means the end of the strings has come. This whatever you have written in the form of one by one, in the same way just like integer array is there, It is an array of characters, so it is called as strings. So character greeting is there allocating the six characters, and your cout statement is there putting that value of greeting message, and the greeting message is nothing but greeting message you have typed here followed with the greeting variable, that is a variable of type character, but it is an array of characters, that's why it is called a string. So you are printing the message hello in that. Okay, so null character is not displayed over here. Null character is known to the compiler, that when it encounters, compiler will just return it that the end is come, so it will just stop the displaying things. Then next is our main thing, that is a class. It is a user defined data type which holds its own data members. I have already discussed class, right? So all these are the data types, derived data types which we have discussed. So everything in C++ is associated with classes and objects along with its attributes and the methods. For example, in real life, a car is an object, and the car has the attributes such as width and the color and the methods such as drive and brake. So you can formulate that example in this case by giving the example of class and objects and make it the class, and allow that their private members as data members. Write down the data members whatever you want, and access methods for that accessing the data members. So you can have that, and then the objects creation. Whenever you object write down the object, it will just allocate the memory for that different data members for that class. Okay, so this is what overall structure, then union, then array, class, pointers, and enumeration, all these are the derived data types. And whenever we say that class is there, the object means the variable of that class. Okay. Then data abstraction concept already we discussed in the earlier class. Data abstraction is nothing but the it's a combination, or abstraction means displaying only the essential information and hiding the details. Okay, so exposure is for the outer layout only. Implementation details are covered out, and the object will just convey that whatever the functionality with the help of the member functions. Functions are used to allocate, or we can manipulate the methods, or use the data members with the help of this object and the dot operator. So class abstraction, this is the example. We can say a private class example. Abstraction example is the name of the class. Privately we have declared the integer number and character ch. These are the two data members. Then the in public we have the set my values as a procedure, or the method, or the function. Then we are having the get my values as a, again one of the procedure. And in main we are having the class name and the object of that class obj. Now how to give the values? By using the obj as an object, dot operator, and you are calling the function set my values. You are passing the values 100 and comma x. So this is nothing but the passing of the values to the member function, and this member function is having the your integer n and character c. So your 100 is goes to integer n, and x is goes to the character c. Now you are assigning these values to your this data members. Num is equal to n value, and ch is equal to c value. How you are assigning? By calling this function. So 100 comma x, these two values goes and it comes to this. Then second function call is object dot get my values. So object dot get my values will have this displaying of this number whatever you are initialize 100 and x to this. It will just assign and now display. So number is now num already assigned here, that is 100, and character ch, it will assign the c value here, so it will assign the x. So this will be for display purpose. When we call out the object dot get my values, this function, this is for the displaying purpose you have written. If you don't write cout, you will not display out these values. So cout statement is like a printf statement in C language. It will display out the values within the variable. It will display out the values within the variables. Okay, so this is an example. You can just write down this example and execute. Then advantages of abstraction. The programmer need not write low level code. It protects the internal implementation from the malicious use and errors. The programmer can change the internal details of class implementation without the knowledge of the end user. We are having the implementation, we are details, we are keeping it only towards only the software who is building it. So we call it as a programmer. Okay, so these details are known to only programmer, not to the end user who is using that. Or he is not much of the knowledge of inside software. Then accessing the class member, how we have accessed the class members with the help of dot operator. So this is nothing, we call it as a dot operator, and it is operator or it is used along with the our object. Whatever is the object, you have to use the object name along with the dot operator to access the class members. So accessing class member is like this. One more example is put up here. Class, my class, then the in public or private, you can specify any type of thing, access specifier, it is up to you. Then attributes, we have used my num string, my string. Then your object declaration of my class, my object is declared, my object dot my num is equal to 15 value. Why I can use assignment operator here? Because I have used access specifier as public. That's why I can assign it. Okay. So my object dot my string is equal to some text. You can write down directly or you are assigning this as it is. So you can do this and find out the what is the output for this. So already we discussed this, what are the access specifier, public, private and protected. How we can write, only we can write here public, private and protected. If you don't write, it is taking as a private only. Okay. So this is what private, public and protected. Then similarly, now how it can be shown to the other class, or this is a class having the private data, having the protected and the public data. So private data is not accessible to the outside world. Then protected data accessible to the derived classes. Whenever the concept of inheritance comes, then we are using the protected access specifier. Okay, so the protected access specifier can be used or accessible to its derived classes, and the public one, it is accessible to the outside world or outside classes also if it is mentioned as a public. Now separating the interface from the implementation, class declaration is the abstract definition for the interface, and the function include the details of the implementation. It is possible to separate interface from the implementation, placing them in a separate files. So we can write the some class and we can just implement that and use that by giving the .h extension wherever that files are needed, and we just include that header file as a header file. So interface versus implement. Interface, the declaration of the class is that interface. Implementation is the definition of the member functions, and interface and implementation are typically separated into two different files. It goes into two separate files. Okay, so interface goes into the rectangle.h and implementation goes to the rectangle.cpp, for example. Then the next is functions. A function is a block of code which only runs when it is called. You can pass data known as parameters to a function, and functions are used to perform certain actions, and they are important for reusing the code. Why to write the code if so same code is repeated again? So just call the function. If it is the code, we have to reuse that writing a code, and we just reuse the code writing, and reducing the writing the code again and again. So that is the advantage of function. So function creation is there. So here we can write the data type, function name, and just call out definition of that function. So I call here with the help of the main function, my function I'm calling here. So calling the function, and your definition is writing somewhere else. So this definition executed afterwards when it is calling here, jumps to your execution starts for the my function over here. It will execute this statement and the output will get here. I just got executed, and only you have to write this apart from this main function. You cannot write the function inside the main function, so you just call the function through the main function, and the body of the function definition you have to write in another space. So function prototypes are needed to tell the compiler that afterwards the function you are using in the space. So this function is having some prototype, and prototype has to be declared first. So it states the return type of that function, what it will return. Then it states the number of argument, how many arguments are passed to the functions. Then it states the data type of the each of the first arguments, and it states the order in which how these arguments are passed to the function. So these things are needed. What are the needed? Function prototype is needed, then the function body is needed, and the function calling is needed. So for the function, three things are needed. So this is the return type, this is the function name, this is the parameter list. So line is called the function header, and it is a return statement. If you want to return the value to the main function, then it is a return keyword. By using return keyword, you can return the value towards the main function. So what is the function prototype? Here is the function prototype, that you are having a return type integer, your name of the function is add, and you are passing the values, that values are integer values, and the two arguments you are passing a and b. So this declaration is called as a function prototype declaration. And actual calling of the function, this is done in the main function. Just you are saying add a comma b, this is the calling of the function. And what is the definition or the function body? This is the definition or function body: void add int a comma int b, here is no semicolon, and then opening brace, return a plus b. That means you are adding a and b value and returning that value. So it goes where it has called. Wherever it is called in the main function, the values is submitted there. So so this is all regarding the function definition, then function prototype, and the calling of the function. So calling of the function is done with the help of the main function. With the help of the main function. So in main function, you are going to call the function which you want to call. Okay, once the compiler knows that this is a calling function, compiler will execute the body of the function, and then again it will return back to the called position. Okay, by giving the return value. If it is there return value, it will just return out that value, and further execution of the program will takes place. So this is what up to the our part. So right now we'll have this stop here. Okay.